Hello friends, so in this series of algorithms today we are going to discuss one more algorithm related to the binary search tree. So here is the problem statement. We have to find out if a sorted subsequence exists in a binary search tree or not. So what does this mean? Suppose we have this set of elements 5, 12, 2, 1, 3, 21, 25, 9, 19, and we will create a binary search tree using this set of elements. And we will when we will traverse the set of elements, or you can say the binary search tree, then we will get a sorted sequence if we traverse the binary search tree in order traversal. So if we do in order traversal, then we will get something like this, right? 1 2 3 5, everything in the sorted order. And we have to find out if 5 12 21, something like this, if any sequence has been given, any sorted subsequence has been given, then we have to find out if this sorted subsequence exists in the binary search tree traversal or not, right? In the sorted subsequence, if this sorted subsequence exists or not, right? This is the sorted sequence of entire binary search tree, and this is the sorted subsequence from that binary search tree, and we have to find out if all these three elements in the same order exist here or not. There is no such hard and fast rule that you need to ensure that there should not be anything between 5 and 12. There can be some element between 5 and 12. There can be few elements between 12 and 21, right? But the whole point is that this sorted subsequence 5, 12, and 21, this should appear in the same order in the binary search tree. Okay, so I have written this function. This is the same function that I'm using for past 3 to 4 videos, and this is the basic logic where I'm just inserting the nodes in the binary search tree. This is the same set of element, and I'm just inserting the nodes in the binary search tree using the same set of elements. And there are three elements 19, 22, 25, which I need to find out if these exist in the sorted subsequence or not. So let's just make it little bit simpler. 5 12 and 21, right? So this sequence exists, 5 12 21, it exists, right? So we need to find out if this exists or not, and this is the function where I have written the actual logic. So this function is same as the in order traversal function, the function that we write for the in order traversal of a binary search tree. Same function has been written here. The only difference is that I'm just traversing it in the reverse order. I already told you in the previous videos that in order traversal, uh, if you do like this, right child to root and then to left child, then if you are following this sequence in order traversal, then you will get the set of elements in the binary search tree in the reverse sorted order, which means in the decreasing order of the elements, right? So greatest to smallest, that would be the sequence if we do like this, right, root and left, right. So this is the way I'm just doing it. Why I'm doing it, like here I have taken a stack and I have pushed all those elements which I need to find out if they exist in the sorted if that particular subsequence exists in the binary search tree or not. For that I have placed all those elements in a stack. So for that I have declared a stack. The name is temp stack. Here I have declared it temp stack, and for that I have used this stack header from the from the STL set, STL STL stack. So that I have used, and in this STL stack I'm just pushing all these elements in the sorted subsequence which we need to find if that exists in the binary search tree sorted subsequence or not, right? So I have just placed them like here 5, 12, and 21. So 21 will be at the top of the stack, then 12 will be there, and then 5 will be there, right? So why I'm doing the reverse order of traversal here, that you might be aware now, that you might have guessed right by now, right? The thing is that I will move from the backward direction, and since this is the greatest element in the stack, so I will be moving from the backward direction. So that is why I have taken it here. So the logic is very simple. If my stack is empty, then what I will do, I will do nothing. I will just keep iterating through. And if my stack is not empty, and then what I will do, I will simply find out if my stack is what is the top of my stack, right? So first of all we will find this element at the top of the stack, 21. So once the 21 will be find out by this iteration, then in that case that 21 will be compared with this end temp, which is the top element of the stack, and both are same. So in that case what will happen, that the top element will be popped from the stack. Once the top element will be popped from the stack, 12 will be there as the topmost element now, right? So this will keep emptying your stack in subsequent iterations, or you can say in subsequent recursions. Here it is recursion. I have used the recursive calls. So in the subsequent recursive calls, these elements will keep popped out, will be kept popping out from one to other, right? So that way it will just pop out everything. And if at the end entire stack becomes empty, then we say that yes, we have found out the sequence. But if at any point of time, if we are able to find out that the topmost element of the stack is smaller than no is greater than the root element, whichever we have visited, whatever root we have visited, the element in that root, if that element is greater than the topmost element of the stack, then in that case we need to stop the recursion right there, because there is no use of recursion ahead, because now we are sure that there will be no such element which will be found in this subsequence, because already the sorted subsequence will be lost, right? Sorted order will be lost. Basically this will lose our sorted order, and that is why we are just returning it from here, and we will do nothing now, right? So this is the way we will identify if a particular subsequence exists in the particular binary search tree or not, right? So in order traversal is the key. You must be aware about the in order traversal, and then you will be able to find it out how you can do that. Okay, so let's see if our program is running fine or not. So 5, 12 and 21, this is the sorted subsequence which we need to find out if it exists in this or not. So what we will do, we will just simply run it. I will not use any hotkey, because there are some other keys which are used for some other purpose on my laptop, and in the last video it just stopped the recording, so all my efforts were wasted. Okay, so here you can see it displayed yes, so it means that this particular subsequence exists. Suppose if I write 5, 12, 18, which is not there, so in this case it should print no. Okay, it has printed no. And if I write like 19, then 19 is there. 5, 12 and 19, 90 is also there. So what will happen? It will display 5 yes. It will display yes, because this sequence exists. So now let us check the boundary conditions. So there are let's take the first three elements 1, 2, 3. So here I'm going to give 1, 2, 3, 1, 2 and 3. So this sorted subsequence also exists, so it should display yes. The result should be yes. Okay, so now let's take the other end, which is 19, 21 and 25. So what we will do here, 19 and 21 and then 25. So what will happen now? It will display yes. Okay, so this is the way it will work, and as many cases you want to run, you can run that and you will be able to find out that it is working fine. So let's see something else as well, like we can say 9, 12 and 19. Let's see this one as well, one more test case. 9, 12 and 91, sorry 19, 9, 12 and 19. Let's see if this exists or not. It should exist, yes, so it is yes. If I write like 9, 14 and 19, then what will happen? 14 is not there, so it should display me no. Okay, so it has displayed no. So that's it. You can test this one, and I hope you might have got the point whatever I have explained here. This is the crux of your algorithm, right? These 6 to I think 8 to 10 lines are there, so these lines are the most important. 11, 12 lines are there. So these are the basic algorithm which will help you to find out if your sorted subsequence exists in a particular sequence, in a particular sorted sequence for a binary search tree or not, right? So that's it. And if you have not got this point, and if you have any doubts, like or you can find out at your end that you are able to find some wrong results, then in that case you can definitely comment on this video. Okay, so have a nice day and bye bye. Please like, share and subscribe my channel.